Hi, I'm Mike Marin, and in this video we'll talk about conducting one-way analysis of variance and Kruskal-Wallis one-way analysis of variance using R. One-way analysis of variance is a parametric method appropriate for comparing the means of two or more independent populations. We will work with a set of data that compares weight loss for 4 different diets. I've already gone ahead and imported the data into R and attached it. We will explore the relationship between weight loss and diet type. We can conduct an analysis of variance using the AOV command in R. To access the help menu, type help and in brackets the name of the command you would like help for, or simply throw a question mark in front of the command name. Before conducting the test, it can be useful to examine a box plot of the data. Here we would like to compare weight loss separated by diet type. In one-way analysis of variance, we are testing the null hypothesis that the mean weight loss is the same for all diets. We can conduct the analysis of variance using the AOV command. Here we would like to compare weight losses separated by diet type. As noted in earlier videos in this series, we may like to save the output of this test in an object. Here, I'll save it in an object called ANOVA1. We can have R return to us a bit more informative summary using the summary command. Here we would like a summary of the analysis of variance we fit. We can see that we are returned the sum of squares, the mean squares, the F statistic of 6.118, and the p-value of 0.00113. Recall in earlier videos in this series, we learned the attributes command. We can use this command to ask R to let us know all that is stored in this object ANOVA1. We've also seen that we can extract certain attributes from this object using the $sign. Here we can pull out the coefficients. Now back to our analysis of variance. Here we can see that we will reject the null hypothesis and conclude that we have evidence to believe not all means are equal. We can use multiple comparisons to help us decide which means or diets may differ from the others. One option is to use the Tukey HSD command. Here we would like to conduct all possible pairwise comparisons for this analysis of variance fit. We are returned overall 95% confidence intervals for the difference in means of all possible pairs. We are also returned an adjusted p-value. If we would like a visual display of this table, we can add a plot command around this Tukey HSD command. Here we can now see a visual display which helps us identify which means or diets differ from each other and which do not. We can edit this plot in the same way that we saw in earlier videos in this series when discussing plotting. For example, we can set the LAS argument equal to 1 to rotate the labels on the y-axis. Let's now talk about producing the Kruskal-Wallis one-way analysis of variance using ranks. Kruskal-Wallis one-way analysis of variance is a non-parametric equivalent to the one-way analysis of variance. We can conduct this test in R using the Kruskal.test command. Just make sure to not let Wallis know they left his name out of this command. Here again we would like to compare the weight loss for different diet types. Once again we will reject the null. In the next video in this series, we will discuss Pearson's chi-square test of independence. Thanks for watching this video and make sure to check out my other instructional videos.